Alright, so this is Mr. C. What we're going to do here is go ahead and go through a practice test. So you'll see that I'm going to utilize the timer once we get started here to talk about pacing ourselves and using certain portions of time and some test-taking strategies. But first, let's go through the directions. So you can see I'm on page 741 here. So that's where the test is at in your book. So prior to watching this video, I want you to actually try and take this test on your own. So if you have not taken it yet, pause. Go ahead and work through this now. If you're watching and don't have the Kaplan book handy, then you can kind of proceed with the video here as a review type thing. But a big part of preparing for the SAT is working at it at your own pace and kind of seeing where you can improve, where you're strong. And again, more practice, the better. So we're going to start with the no calculator section. Here we can see we have 20 questions in 25 minutes. So just some notes here. Key idea here, the available space on each page may be used for scratch work. So write all over this thing. Again, just make sure we fill in our answers clearly. Calculator use is not permitted. All numbers used are real numbers, and all variables used represent real numbers, unless otherwise indicated. So the complex number system, that full number line with A plus BI stuff, doesn't exist unless they tell us specifically it does for a given problem. Again, can't use calculator. Pretty self-explanatory there. Figures are drawn to scale and line a plane unless otherwise indicated. So that's actually a big little hint there for us from approximation. So figures are drawn to scale. On most tests it says they're not. So that's something we can maybe make use of. And lies in a plane just means they're two-dimensional unless, again, otherwise specified that we have some three-dimensional shapes. Unless stated otherwise, the domain of any function f is assumed to be the set of all real numbers x, for which f of x is a real number. So basically means we're thinking of there's no holes, there's no asymptotes, unless we're specifically told otherwise. So here's some nice handy formulas. What's nice about the SAT is they don't expect you to memorize this stuff. So special right triangles over here, Pythagorean theorem, how to find the area of a triangle, area of a rectangle, area of a circle, also circumference of a circle. That one always seems to come up, so just make note that it's there. And again, practice makes perfect here. Familiarizing yourself with this test, being able to quickly reference pages, flipping back and forth. I would kind of maybe dog ear or fold this one when I was going through it just to flip back to it. We have the volume of a rectangular prism, volume of a cylinder, volume of a sphere, volume of a cone, and then volume of a, this is a square pyramid or a rectangular pyramid for that matter. And then just some extra facts here. The sum of the degrees of the sum of the degree measures of the angles in a triangle is 180. The number of degrees of arc in a circle is 360. So that means 360 degrees around for a circle. And the number of radians of arc in a circle is 2 pi. So converting there. So again, we can remember how to go from one to the other. So if you forgot that formula offhand to convert from degrees to radians, we can actually break it down from here. All right. So let's get started here. Okay. First thing we're going to do here is kind of scroll through. Oh, I'm going to scroll. It's on the screen. I would suggest you flip through. Look for problems that look familiar. So this is the whole practice test. Meaning it's not just one section of the review book here. So this is similar to exactly what you'd see on an SAT, just with different questions. But the proportions of certain question types are going to be the same. So a quick strategy here, and I'll pause in a moment, and then we'll start our official timer of when we can go ahead and quickly identify stuff we should start with first. So we're at about 4 minutes here, so we want to make sure we finish this test by 29 minutes or so, because that gives us our 25-minute time limit here. So first, skimming through this, if we read through this first problem here, we see we're given a linear equation, and then it's basically just asking us what this part of the equation deals with here. So I'm going to go ahead and identify question 1 as something that's probably pretty quick to do. Looking at question 2, it's squared. Maybe I'm familiar with that. I'll probably save that one for later. Question 3 here. Here we're given a graph of a parabola. This is something we've all seen a lot of times, so let's go ahead and identify that as a starter problem. 4, okay, let's see. I got a graph. Having a graph is good. Let's see. It's a linear equation because it's a straight line. So let's go ahead and we'll get to that one in the first set. 5. The following represents t in terms of the other variables. So we're solving for t. It may look like it's got a lot of variables, but for those of you that have taken our Algebra 1 course, you've seen this equation about 500 times, right? So it's linear. Let's go ahead and throw that in our first set. 6, parabola. We'll come back to that one. 7, this is just intersection of two lines. So let's go ahead and identify that one here. So again, you'll notice the key here is I'm looking for linear equations. I'm looking for things that are represented with a largest exponent of 1. Because again, we've worked a lot with those. An inequality, but still the exponent on the x is 1. So let's go ahead and signify that as one we could start with. And looking at, let's see, 11. Notice I'm kind of hitting these last lines first here of each question to figure it out. It's given a table. Which linear function? So I see linear. So let's go ahead and anything linear is always a good place to start. 12. Oh, it's linear, but that one looks kind of big. Let's save that one for the end. 13. Okay, I see some linear equations. Let's go there. 14. It's involving trig. Let's save that. 15. Some exponent laws. We'll save that one as well. Okay, so now we're on to the grid-in. So definitely familiarize yourself with these. Go through a couple practice examples here of how to bubble in the correct answers here. Worthy of reading over, but for the sake of our practice test, we'll kind of fast forward through. So I'm looking here, I see some inequalities. They're linear. I have some nice shading already, so let's go ahead and we'll do 16 there. 17, linear. So let's go ahead and throw that in our first question set. And if we look through these, I see a circle, so I know I'll need that formula at the front. Diameter of a circle, another formula at the front. And this is just a very long-looking word problem, so we'll save this for the end. All right, so now we're at about 7 minutes, and we said we had till 29 minutes, right? So that leaves us 22 minutes now. So we briefly went through just identifying those first problems, those ones that we need to get right. Okay, so for this first one, a biologist develops the equation y is equal to 20.942x plus 127 to predict the regrowth of a certain species of plant x months after a natural disaster occurred. Which of the following describes what the number 20.942 represents? Well, if we just think about this equation of y is equal to mx plus b, m is represented here as our slope. It's the change. It's how often things occur. This one is just basic vocab of linear. If we look through here, a wouldn't make sense. That would be what y represents. C wouldn't make sense because that's a positive number, so it's increasing. And then here, the estimate number of plants that survive, that would be kind of our b. That would be what we start with. So our correct choice here would be option B. The estimated monthly increase, because it's positive, in the number of plants. Alright, so we're looking at question 3 next. Which of the following could be the factored form of the equation graphed in the figure shown? So first thing here, whenever we're given a graph, is we have to figure out the scale. So we look at our x-intercepts here. So I'm seeing that 1, 2, 3, 4 jumps represents getting to the number 1. So if I think about that, each grid line here, each jump represents 1/4. So that puts my zeros here at negative 2/4 or negative 1/2. So in terms of an equation, that would look like x plus 1/2. Because again, when we write these equations, we want to think of it being the opposite or working backwards. Here we went to the right, so it's positive, and therefore it would be x minus 3/4. So again, when we write equations, we work backwards. Now, kind of working backwards from factoring here, we can rewrite this by putting our 2 out front, because solving it would still yield that same answer. So this term is represented by 2x plus 1. And this term, using that same trick of bouncing the denominator in front, would give us 4x minus 3. As we see here, when we're looking to match up, that gives us choice A. Alright, moving on to question 4 here. Line P is shown in the coordinate plane here. If line Q not shown is the result of translating P left 4 and down 3, then what is the slope of line Q? So, if we take a look at this one here, we're getting this line Q here by moving left 4. So if I just pick some point like this one, I move left 4, down 3. We see that we're just moving horizontally and vertically. That doesn't change the slope. So if we just count the slope from our equation here, we can kind of see the points they gave us here. We can just count it off. If you're not given, just pick where it intersects at nice like kind of whole numbers here. It's easier to count. Remember, always count from left to right. So if it's going up from left to right, it's positive. Down from left to right, it's negative. And here we'll arrive at choice D. It's 5 over 2. So we quickly eliminate A and B because those are negative, and then just seeing which one of these is correct. Alright, on to question 5 here. Basically, we can read through this. We want to get T by itself. So the opposite of dividing by T would be multiplying both sides by T. And then if I want to get A out of here, I would just divide both sides by A. It's already on the bottom here, so I just put it there. Which will arrive us at choice B. So again, just knowing how to work with those literal equations, reworking them. 6 we skipped. Okay, 7. So here, AB is the solution to the system of equations, so it's signified there by that nice intersection of those lines. Then we have our point there. So first thing we need to do here is figure out the scale. If I look, I make 1, 2, 3, 4 jumps to 2. So 2 divided by 4, that gives me 1/2. So the scale here, each jump is representative of 1/2. So if we kind of use that, so if we think about our intersection here, so I'm going to the left, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that intercept there is represented as negative 10 over 2. Going down, if we count again, we can see that this is going to be 1, 2, 3, 4, 5, 6, 7, 8. So since I'm going down 8, that's represented as negative 8 over 2. So some quick conversions here. That'll give me negative 5 over negative 4, and negative 4, I should say, not over. And if we add the two, well, negative 5 plus negative 4 gives me negative 9. So that'd be choice B. Moving on, we said we'd skip over these. So we're on question 10 now. So here we got some fractions, so I'm going to work through solving this here. So we distribute first, so that'll give me 3 over 5x. Plus, when we multiply fractions, we do the tops, and then we multiply the bottoms. Now, what we need to do here is we're going to subtract from both sides. So I'm going to go ahead and subtract over. So I'm going to do negative 6. I'm just going to work to the side here, minus 6 over 35. So first thing we need to do is get a common denominator. So to do that, I need to make this a denominator of 35. So if I multiply this and divide it by 35, I'm not changing the number. So again, do some work to the side here, but negative 6 times 35 would give me negative 210 over 35 minus 6 over 35. So when we subtract those, when we subtract fractions, we need a common denominator and we leave the top the same. So this will give me 3 over 5x and then negative 216 over 35. Now, we have this here, so we can multiply both sides by the reciprocal. So if I multiply both sides by 5 over 3, we'll get x is greater than. And now, remember, if you multiply or divide by a negative, we flip the inequality. But since we have a positive here, we're going to leave it the same. When I work through this here, so some canceling here to avoid some giant by hand math, we'll have a 5 on top and a 35 on the bottom. Those kind of work together there, so 5 over 35 would give me a over 7 here. So that would be negative 216 over 7 times, because 5 of that reduces to 1 over 7, right? And then when we go ahead and simplify that there, we're essentially doing negative 216 over 21. So I'm just going to work to the side here, negative 216 over 21. Here's where some nice by hand math comes in, but when we reduce this here, we'll get to choice A. So again, practice dividing by hand, long division. That's going to come into play on this test. Looking at number 11 here. So again, we just basically wanted to figure out what this equation is from the table. If we're looking here, so first thing to notice here, these are all just giving us the slope, which means we're not really worried about a y-intercept. So if we just find the slope, let's use dropper and syringe, right? So the way they're giving us this, it's in terms of s. So s acts like our y here, whereas d, the dropper, is going to act like our x variable. So this is like my dependent y and my independent x. So if I think of the slope formula here, this would be our s's, so we could subtract s's on the top, and then subtract our d's, or our x values there, on the bottom. And again, you could do 2 then 1 on both. Just match it up the same way. So I would use this is d1 and s1, and then I would use this as D2 and S2. Again, just kind of working through there, so we'd have 1.25 minus 2.5, which would give me negative 1.25. And then on the bottom, I would have 0.5 minus 0.1, which gives me negative 0.5. Well, a negative over a negative, that gives me a positive. And then when I go ahead and divide that out, I'm dividing by 0.5, dividing by half. Again, this is just that kind of by hand practice that you'll need to do, but you'll arrive at a slope of 2.5. So our answer would be choice D. Alright, so let's look at 13. Okay, so zoom in a bit here. If the solution to the system of equations shown above is 2, negative 1, what is the value of k over h? So we're given a lot of variables, but we're told what the solution is. So essentially that just means we're going to plug in here. So for my x's, I'm going to plug in a 2, and my y's, I'm going to plug in a negative 1. That's what a solution means. It means it makes this statement true. So what we don't know are these values of k and h. But when we set this up, we'll see that we're capable of solving. So if I solve the top one, I will end up with h being equal to negative 3. When I solve the bottom one, I'll end up with, let's see, we have 5, add it over. We'll end up with k is equal to negative 9. Because here, when we subtract this, we'd have negative 18 divided by 2, negative 9. So then our value, k over h, we see that reduces to, well, negative divided by negative is positive. 9 divided by 3 gives me 9. So choice D. Alright. Moving on here. And again, you'll notice a lot of this stuff I'm kind of calculating as I go here in my head. That's to make this video as short and to the point as possible while still staying in the time constraints of the test. You'll notice that the biggest skill you need is the ability to do mental math. The ability to kind of quickly know that 2 times negative 1 is negative 2, that negative 5 times negative 1 is positive 5. And that's just practice. That's just keeping your skills fresh and, again, working through these things. Challenge yourself to do your homework without a calculator. Alright, so looks like we're back to here. Okay, so we said 16 was a good one. Okay, so the figure shows a solution set for the given system of inequalities. Suppose that A comma B is a solution. So a solution means it's in the double shaded area, right? So if we look here, we kind of see where that's at. So that's going to give us this portion here where the grid lines are both crossing. If A is equal to 0, what is the greatest possible integer value of B? Okay, so A equal to 0. If we have A comma B, that means our xy coordinate here, that AB is going to be 0 comma whatever B is. So we're seeing what the greatest possible integer value. If we're looking here, so integer means a nice whole number, right? So positive or negative it can be. If we're looking here, the greatest would be as high up as I can go on this y-axis, right? So if I'm looking here, greatest possible integer value, well, x is equal to 0. That means I'm on the y-axis, or the y-intercept. So if I look closely here, it does go through positive 2, but if we remember inequalities, a dashed line means those aren't included in the solution set. So it's going to be less than 2. And I can see here that the greatest possible integer solution would be right here at positive 1. So our answer for this one, we would just grid in 1. Again, just kind of reviewing how to read those solution sets. Not a whole lot of work there. It's basically a do you know this or not type problem. Alright, let's look down here at 17. Given the function f of x is equal to 2 over 3 times x minus 5, what input value corresponds to an output of 3? Well, an output of 3 means f of x is equal to 3. So the input is our x, so which means we just need to solve. So I'd add 5 to both sides. Multiplying by a reciprocal, that would be multiplying both sides by 3 over 2. Which would give me 12. So I would just grid in 12. Alright, at this point we've exhausted ourselves of all these kind of go-to, quick and easy linear problems. So at this point we're going to go ahead and then go back now and do the rest of them. So I'm going to go ahead and just start. So at this point in the test I would flip back to that start because again, usually the first couple tend to be easier. Not always true, but kind of a rule of thumb. So let's go back here. Looks like we still got to do, we did 1 and 3, let's do question 2. We got about 10 minutes left as well in this portion of our short answer. Okay, so going on to question 2 here. Which of the following expressions is equivalent to 25x squared minus 4 over 9? So in this case, I can kind of rule out A and B. The main reason is because there's no way I can get a square root and get back to that. Square root's smaller, right, than squaring. If I look through choice B, okay, that's 5x squared minus 2/3 x. That's not going to work. Here I would suggest just kind of checking C and D. So being able to rule out A and B here gets us down to a 50-50 shot. If we work through both of these, we'll see that D does not come out to that, because when I multiply this out, I'll have 625 or so x squared. There's no way that's going to get us to 25. Whereas if we check option C, that's actually just the factored form of that equation we're given. Let's go on to question. We did these. We did 5, so we're on to 6. Okay, so for question 6 here, could represent a parabola, minimum value of -5. Well, if we remember kind of our parent function here, it looks like this. So minimum value of -5, that corresponds to a k value here of -5. So not A, not B. And then it says an axis of symmetry is the line x is equal to 1. So if we think about our opposites here, right? So +1, we think of the opposite in here. So that gives us h is -1. So remember, inside the grouping symbol, we always use opposites. So this gives us choice C. 7 we already did. Checking out question 8 here. So for this one, we have what A is and what B is. What is the value of 3A plus B? So here it's actually just kind of plugging in, being able to combine like terms and solve. So if we plug in here, we have 3 times x squared plus 4x plus 9, and then we're just adding B here. So I don't need any parentheses because I'm not distributing anything. Let's go ahead and multiply it out by distributing that 3. And then we just combine our like terms here. So when we combine, and they like get written in kind of descending order of the exponents here, we'll arrive at choice C. Alright, looking at question 9 here. So this deals with the discriminant. So that's part of the quadratic formula. That's x is equal to opposite b plus or minus square root b squared minus 4ac all over 2a. So the discriminant deals with the number of real solutions here. So real values. To find that, we would calculate b squared minus 4ac. If this number is greater than 0, there's 2 real solutions. If it's equal to 0, there's 1 real solution. And if it's a negative number, there's no real solutions. This just comes from how the square root function works. Here, when we calculate it out, we'll get 0. Again, this is our A, B, and our C. So that would tell us that there's 1 real solution. Now we did 11. We're on to question 12. So, which of the following equations, when graphed on the coordinate plane, will not cross the y-axis? In this case here, what we want to think about is we want to get these into the form of y equals mx plus b. So I would go ahead and solve each one of these here and get the y isolated. So isolate the y by itself. When we work through these, we're thinking of here not crossing the y-axis. So we're looking for something where those y's actually cancel, and we're just left with x equals some number. So if we look at that, once we go through kind of just solving, and again, there's no short and quick way to do this, it's just kind of by hand math, you'll arrive at choice C. In this case, we'll end up with x is equal to 5. So with that x equals some number, that's a vertical line. It'll never cross the y-axis. The slope of that is undefined. Alright, moving on. We did 13 on to 14 and 15. Okay, so for 14 here, we have given that sine of A is equal to k, where A is an angle measured in radians, so between pi and 3 pi over 2. If we know our graphing here, so this is 0, 2 pi, this is pi over 2, pi, and 3 pi over 2. So it's between these two, so it's somewhere over here. If sine of b is equal to k, which of the following could be the value of b? So here we know that it's going to be a negative number for sine, right? Because sine is negative. So all positive, students, sine is positive. Again, if we think of sine as our y value, it's positive on the top and negative on the bottom. So we want some type of negative answer, k. So if we think about this here, if sine of b is equal to k, that means that's a negative as well. So the only place sine is negative is either quadrant 3 or quadrant 4. So if we think about trying to get around here, we can kind of eliminate that idea to get a negative k. So for a here, if we're looking here, if we subtract pi, so that would be getting us this direction. It's not going to be negative. If we think about here adding pi to that angle A, alright, so if I add pi, still not going to be negative, right? If I look at C, this is going to be a positive here, so we're going to go ahead and do negative A and then add 2 pi. So negative A would put us up here. Adding 2 pi would be going around the circle 1 full time. Then, if we look over here, choice D, that's going to be negative A, so getting us to the opposite area there, and then going around 1.5 times, which will get us to the correct location. This one is just going to be a lot of review here. If you could eliminate choices just to C and D, you're kind of in a good place. So here, we'd end up with choice D. Alright, moving on here. And again, this one is probably something that high school me would have narrowed it down to C and D and just took a guess on. But again, that's okay. We're not going to get every question right. Alright, looking at 15 here. So, knowing our exponent laws here, what I would suggest here is let's simplify what we're given first. So if we distribute this 2 to both, that would give me x over 2 times a half is just 1, right? So it's just x. And then over negative 4, well, negative, we bring it to the top. So this would be x to the first times x to the fourth. Exponent laws give us x to the fifth. Here I would just go ahead and reduce and simplify each of these. It's definitely not A, right? When we reduce this one, it's not going to work. This one, a lot more complicated looking, but it's not going to work. D is going to end up being our choice. So I'm just going to pause the video real quick here to keep us in our timeline since I am explaining these and show you the work needed to get to this. So here, I would combine the top, the bottom, right? We can bounce that up. That combines then, x to the 10th, 1/2, half of 10 is 5. So again, just reviewing those exponent laws. Alright, so let's go ahead down here. We were on question, so we got 18, 19, and 20 left, and about 1.5 minutes left. A little long-winded as a teacher. So for 18 here, what we're going to end up doing here is going to be utilizing a few ideas about a circle and knowing that we want to find the diameter. Okay, so first idea here, we see we got 60 degrees. Well, that's 1/6 of a circle. So 1/6 of 360 is going to be how much of that we want. So if we look around here, we know that the area of a circle is equal to pi r squared. So if we think about this here, we can find out that our area is going to be 1/6 of that whole circle. And it says the area of the shaded sector is 6 pi. So the area of the whole circle would be 36 pi, right? Because it's 1/6, so we times 6, right? So 6 times 6 gives us 36 pi. And then we could go ahead and set this equal here to find our radius. So the pi's will cancel, we'd square root. Wouldn't make sense to have a negative here. So our radius is just going to be 6. So then if we go ahead, the diameter is twice the radius, so 2 times 6 gives us 12. Alright, looks like we're going to go a little over our time limit here. Downside of trying to explain things while you're doing. So again, forgive me, it will be a few minutes over. We'll go back and talk a little more as well here. So what is the diameter of the circle given by the equation here? So for this one, to figure out the diameter, we need to get this in our standard form. So if we go ahead and think about completing the square here, we'll get our x terms together. And we're going to leave this plus blank. I'm just going to zoom in a bit here. And again, we're going to complete the square, so we'll leave it blank. And plus y squared minus 4y plus blank. And that's equal to our constant term there of 20. So completing the square, we divide our b term by 2 and square it, so b over 2 squared. So that's going to give me 25. So that'd be just 25 there. Let me erase this part, didn't mean to write that. And then negative 4 divided by 2 is negative 2. Negative 2 squared gives me 4. So since I'm adding these terms in, I'm also going to add them in over here. Then we know with our standard form, this is a perfect square, so it'll factor down. Right? So if we factor this one up with x plus 5 squared, then here it would be y minus 2 squared. And then when we add these terms up, we'll end up with 49. So knowing the way this equation is presented, what we're going to do here is then go ahead and the radius is represented. This is the radius squared. So if I take the square root of that 49, that'll give me my radius, which is just going to be a positive 7. And again, we can ignore the negative because we're talking about a length here. And then the diameter is 2 times that. So 2 times 7 gives me a diameter of 14. So you definitely want to review some of that working with the equations of a circle. Okay, last question on here, working through question 20. So, in economics, the law of demand states that as the price of a commodity rises, demand for the commodity goes down. A company determines that the monthly demand for a certain item that it sells can be modeled by the function Q of P is equal to negative 2P plus 34, where Q represents the quantity sold in hundreds and P represents the selling price in dollars. It costs $7 to produce this item. How much more per month in terms of profit can the company expect to earn by selling an item at $12 instead of $10? So what we're thinking of here is essentially 2 separate parts. So we have our $12 scenario and our $10. So we're comparing which one's going to give us the better result. So the first thing here, let's go ahead and plug in here, because you think about this, a profit is equal to sales minus the cost, right? It costs us something to make it, so we want to sell it for more than what it's going to go ahead and cost us there, right? So if we plug in 12, so if I find Q of 12 and then Q of 10, so I'm going to do this kind of side by side. So when I plug in for the first one here, I'll end up with 10, and over here I'll get 14. So, and again, we're thinking of this being in hundreds. So if I multiply each of these by 100, in this case, how much I'm going to be totaling in sales, 10 times 100 gives me 1,000. And over here, I will get 1,400. So that's representative of our sales, right? Now we need to get rid of our costs. So if we move down a bit, actually didn't mean to write dollar signs there, my bad guys. So what this is actually going to be the quantity sold in hundreds. So that's how many hundreds of items we're selling. So this wouldn't be dollars. That's just going to be how many of those items we're selling. So if we move down here, if we're thinking about how much we're making in sales, so we're selling 1,000 items for $12. So if we multiply those two, what we're actually making is going to be $12,000 here. Over here, if we're selling it for 1,400 items for $10 each, again multiplying by 10, we'd have $14,000. We figured out thus far is going to be how much our sales are, right? So that's how much we're selling in each case. So we have 12,000 versus 14,000. Now, when we think about these costs here, it's the quantity of items that we're making. So for costs, which is this portion of our equation, in our first case, we're making 1,000 items. So 1,000, and it says it's $7 for each item. So 1,000 times 7 is what it's going to cost us here, about exactly 7,000. Over here, we actually made 1,400 items. So 1,400 times 7 is going to give me 9,800. So again, just multiplying out by hand. So in this case here, we can actually see that it's costing us more money because of how much we're making. So if we figure this out now to figure out our profit, I would subtract these two. So the sales minus the cost. So when I subtract these two, I'll end up with 5,000. Over here, when I subtract these two, I'm going to end up with 4,200. So when we go ahead and subtract those, because we're asking how much more can they make, I'll find out that my final answer is going to be $800 more. So I would just go ahead and bubble in 800. Now, as you can see, we went a little over the time limit here. And that's the kind of downside to explaining things as you go. So what I would suggest doing, again, the key strategy here is identifying what you know you can do. And again, how quick you can do that is just a matter of how many times you've practiced. You'll see a similar breakdown in all of these tests. So if we look up here, again, the first set of questions we identified was kind of our key. That's what gave us the idea of where we could start. Now, in a test-taking scenario, another strategy might be looking through a question is when you see you can do it, just go ahead and do it. I just wanted to model in this video a process of how I can look at a question and know whether or not it's something I should start with or something I should end with. But again, the best preparation is day-to-day, doing a couple problems, whether it's using Khan Academy, when linking it to your SAT, PSAT practice test, or just, again, working through these videos. The more of these videos, I'm not going to lie, I have made so many hours of these things. You have unlimited resources, essentially, and know that you can always contact me. The easiest way to email would be JC. I'm going to write that down. This would be my school email address here, which you can always contact me at if you have questions about the SAT. So JCIOLKOSZ at jths.org. And again, I'd be happy to provide you with more links to the resources, or you can follow me on Twitter at J_Ciolkosz. J_Ciolkosz. And it'll just say Mr. J. Ciolkosz on there. And it's always going to be the pinned tweet. That'll link up either to a Google Drive with some videos, or ideally at some point here, I'll go ahead and make a YouTube channel just so it's easier to view on the go on a mobile device. But again, always feel free to reach out to me via email too if you have questions about any SAT questions related to math or preparing for it in that way. All right. What we're going to go ahead and do now is move on to our multiple choice section. Because again, we're going to do the whole test at once here. So let's go ahead and move on down. All right, so let's take a look at what we got here. All right, so for this portion, we have 55 minutes to complete 38 questions. And we do have a calculator. So what I'm going to do is go ahead and open up my calculator here. Yours might look a little different, but that's fine. Let's see if I can get it to be the right size here. That should get the job done. Okay, so what we're going to go ahead and do here is just work through again how to solve this thing and work through it in that way. Let's go ahead and review a few things here. So for this case, calculators are permitted. And we'll see that these are the exact same disclaimers we already discussed. They give us the same formulas. So again, if we forget something, we can reference it. All right, so let's work through question 1 here. All right. In this case, we're not going to do the strategy so much of kind of going through. We'll just go through each problem here to get a little more of the practice side of it in. All right, so the USDA recommends that adult females consume 75 milligrams of ascorbic acid. Not quite sure what that is, but we'll be good. Also known as vitamin C. Well, that's what it is. Okay, each day. So what I'm going to do is show you a little trick here of reading the end first to figure out what it is I actually am trying to find here. So let's see. Which of the following inequalities represents the possible intake of grapefruit G and spinach S that a smoking female could consume to meet or surpass the USDA's recommended amount of vitamin C? So in this case here, what we're trying to look at is just how much of those two things. So if we look here, we want 75 milligrams. It inhibits it when we smoke. So we need an additional 35 daily. So if I think about adding those two, that means I need 110. All right, so 75 plus 35. So let's look through our answers here and see what we need. I can get rid of A. That doesn't have being greater than or equal to that, right? So we need at least 110. So that gets rid of actually choices C and choice A, because this is greater than or equal to 75. This is just greater than 110. We know it's greater than or equal to, because that's saying that's the bare minimum. So it's the vocab there. It says here 1 grapefruit is 40, and 1 serving of spinach is 10. Well, if we think about these two choices here, this makes absolutely no sense in terms of per item. So 40 per grapefruit would be 40G, and then 10 per spinach would be 10S. So our choice here is going to be B. So that's just kind of reading through the vocab. All right, moving on to question 2. So go ahead and let's read that. Oh, I do not know what just happened. 1 second. There we go. And we're back. That was a review for a unit there. All right, so go ahead, take a minute, and let's read this thing on our own. All right, so again, hopefully we glanced at the last line here. Which of the following best represents the meaning of the slope of the line of best fit in the context of this question? So the slope is kind of how things are changing. It's the rate at which things go. So we're seeing the daily minutes of watching commercials, and as it goes up, the amount spent per week in dollars goes up as well. So if we read through these, the only one that's really going to make sense here is D, the predicted increase in money spent on brand name products for every 1 minute increase in time of spent watching commercials. The reason why the others don't make sense, this doesn't make sense with $0 on brand name products because we see that we have the dollars going up here. Choice B, the predicted amount of money spent on brand name products when a person spends zero. So we keep talking about this $0, 0 minutes. We see here we have a graph that's rising from right to left. So we know it's going to be growth. Here it's talking about increase in time when you're spending dollars. That's just kind of backwards. So the key idea here is the dependent variable, our money, is caused by our x variable, our independent time. So as time increases, so does our spending of money. All right, on to question 3. So here we're given a bunch of systems of equations, right? So there are very few states in the United States that require public schools to pay sales tax on their purchases. For this reason, many schools pay for student portraits and the parents reimburse the school. Parents can choose between the basic package and the deluxe package for the prices that are given there. We have 182 parents ordered them. The school's total, they gave us our total, right? Which of the following systems, the number of basic packages B, and the number of deluxe? So we said we have 182 people who ordered this, right? So that gives me B plus D is equal to 182. Because B and D are the number of packages or people that ordered. We said 182 ordered packages. So right off the bat, I could eliminate A. That doesn't make sense there for C. Okay, so now we're down to B and D. For our other one, we're seeing here that it's going to cost us that $29.50 for a basic. So that's like 29.50 B. And then $44.50 for our deluxe, and it's equal to that total of 6,509. So 6,509. We can see here that our choice is B, that we don't know why they're dividing by 2 there. It doesn't make a whole lot of sense. All right, moving on to 4. So, the graph of a polynomial function, that just means x to some power probably other than 1, right, is shown above. For what values of x does p is equal to -4? So that's saying our output is -4. So we look at our scale as 1, 2, 3, 4, 5, 6. So just by 1, so -4 would be at 1, 2, 3, 4. So we're looking where it hits this value. So just looking at our x values here, we see that that is going to be at -7 and then at +5. So our choice here for 4 is C. All right, question 5. If 4x plus 3 is equal to 19, what is the value of 4x minus 3? So here we see we have one variable and a bunch of constants. So we can go ahead and solve that. So if I subtract 3 from each side, that'll give me 4x is equal to 16. Divide, I'll get x is equal to 4. Plugging in that 4 here, 4 times 4 is 16, minus 3 gives us 13. So our answer is C. Similar questions to this is on pretty much every single practice test that I've done. You'll probably see one similar. Calculating slope, this is kind of just a by hand thing, so picking some nice grid line points here. Right, so we see where it intersects some nice whole numbers. There's another one up there. You could have used this one as well. So you always want to pick those nice whole numbers. Just counting off this slope here, we will see that our choice is C. It's going down from left to right, so we can eliminate D. It's definitely a negative number. And we get that -6/7. So rise over run when we count slope. And always start from the point on the left and go to a point on the right. Alright, go ahead and let's take a moment and read over question 7. Again, if you're working through this practice without the book in hand, just pause. I'm trying to kind of zoom here accordingly so you could have a moment to read it. Alright, so once we read through it, based on the graph, which of the following statements is true? So we have state A as our solid line, state B as our dashed line. So it's saying years after legislation, so as the years increase, what happens with the crime rate, right? So we can see both are decreasing, so that's a good thing, right? Less crime as time goes on. If we're looking through, so let's look at A. State A's laws had a more positive impact on the crime rate for armed robbery. So, if we're looking, right, the crime rate's going down, but so did this one, right? They both end up going down. So, they can't really say they're equal, right, because we're both going down. And if we think about it here, it looks like A is actually decreasing a little slower, right? It's not as steep of a line here, state B. So that one's not going to make sense. C, they have the same impact. That would mean the lines are the same. They're not. D is that option. Well, we can't determine it. But if we look here, we can actually see that state B is decreasing faster than state A, right? So that means B is going to make sense, because positive crime would mean crime's going down, right? So since B is decreasing faster, our choice here is B. All right, looking at 8th here. On average, for every 2,500 cans of colored paint, a home improvement chain mixes exactly 40 are the wrong color, or defective. At this rate, how many cans of paint were mixed during a period in which exactly 128 were defective? Here's a proportions problem. So we had 40 defective for every 2,500 we make. So to figure out how many total we'd make to get exactly 128 defective, we could just call that X. So we could multiply here. So I'd have 40X is equal to 2,500 times 128. It's a calculator section. I'll leave that one up to you guys. And then solving here, we would end up with X is equal to 8,000. So that'd be 8,000 cans. So again, proportions are going to be a key strategy we see a lot of time. Okay, so we're looking through our prompt here. Our goal is here, which of the following must be true about the combined mean age, M, of all people with college degrees at their first marriage? So here it says the age of men is 29.9, and the age of women is 28.4. Well, if we think about how we find an average of the two, that would mean that we'd add those two numbers and divide by 2. So it's not necessarily going to be this perfect outcome, right? But when we think about this, basically what that means is when we find the average and we add up all our samples and we divide it, what's going to be nice about it is it's definitely going to be between those two numbers, right? There's no way I can take a bunch of samples, add them together, and get something that's outside of that range. So kind of logically deducing here, D is going to be our choice for this one, because that's exactly what it's saying. It's going to be somewhere between those two. It's surely not going to be greater or less, or exactly equal to, because if we add these two together and divide, that's where we're going to get that 29.15. But the reason why we can say it's going to be somewhere between our male and female average is because that, again, dealing with how many come from each sample, it might skew it a bit, so we can't say it's definitively greater than, less than, or equal to that 29.15, but we can definitely say it's between the two. All right, looking at question 10 here, we're going to deal with another proportion, right? So when scuba divers ascend from deep water, they must either rise slowly or take safety breaks to avoid nitrogen buildup in their lungs. The length of time a diver should take to ascend is directly proportional to how many feet she needs to ascend. If a scuba diver can safely ascend 165 feet in 5.5 minutes, how many feet can she ascend in 90 seconds? Okay. So let's do some conversions here. So first off, we know that we can go 165 feet in 5.5 minutes. So we want to figure out how many feet in 90 seconds. Well, to go from seconds to minutes, I would divide this by 60. Just like if I wanted to go the other way. I could also multiply this 5.5 by 60 to convert to seconds. Either way, we're going to end up with the same answer. I just chose to go this way, so that gives me 1.5 minutes. Again, kind of multiply our cross-multiplying strategy here. We'll end up with X is equal to 45. So choice A. So you can go up 45 feet. All right, go ahead and take a minute here and read through 11. Okay, so for this one here, our last lines here, which of the following inequalities gives the number of pairs of shoes P that the company needs to sell in order to make a profit? So if we work our way through this one here, we have our equation, right? So that's the cost of producing. So that's kind of one side here. So that's our cost. And in order to make a profit, we'd want it to be greater on this side, right? And we're selling it for $35 per pair. So if we go ahead and solve this one, we could subtract 17p from both sides, divide, and we'll end up with p is greater than 105. So it'd be choice D. So again, just working with writing those equations. And again, once we get through this video of doing the work on here, I'm actually going to reference a bunch of other videos that are kind of going to be good practice for that. Alright, so here on to question 12. How many calories would an athlete biking a 74-mile race need to consume, assuming he bikes an average speed of 9.25 miles per hour during the race? Okay, so again, you notice I'm always reading that last part first. So here we have, the human body has a very limited ability to store carbohydrates, so it's important for athletes to consume them during long training sessions or competitions. It is recommended that athletes consume 3 calories per minute in situations like these. So, if we think about this one here, we're going 9.25 miles. On the other hand here, it says we're using a 74-mile total race. So notice my distances are the same on both sides. So what I'm trying to figure out is how long this is going to take, right? So if I throw this is over 1 unit of time here, right? So 1 hour. So per hour, I can go 9.25 miles. So this is going to be X for how many hours it takes. Through solving this, we'll end up with finding out it takes exactly 8 hours. So it's saying I need 3 calories per minute. So little conversions here. Well, minutes to hours, I would do 8 times 60, because there's 60 minutes per hour. That gives me 480 minutes. Then if I do 480 times 3, because per minute I need that 3 calories, I'll end up with 1,440. So again, going from conversions to fractions, proportions, a variety of ways to solve these. Okay, 13. We have a linear relationship, and we need to find the missing value, so that question mark located here. So missing y value. So first thing I would do is find the slope. So I'm just going to use my first set of points here, and then I'm going to use my second set. You can use any of these. Obviously don't use this one. We don't know it. So once we calculate that, you should end up with a slope of -7 over 2. Right? So I would subtract my y's, so I could do 0 minus 14 and 3 minus -1, which gives me -14 over 4, reduce, -7 over 2. Now to find that b, I can go ahead and plug in 2y equals mx plus b. I'm just going to go ahead and use this one because it's got a 0 in there, right? So I got 0 is equal to -7 over 2 times the x value is 3 plus b. A little bit of solving here. We'll end up with b is equal to 21 over 2. And then lastly here, we need to find that missing value. So just plugging in to find that y value here. So I have y is equal to m. That's our slope. The x that goes with it is -7. And our b we found was a positive 21 over 2. So you can literally just plug this into a calculator and it'll end up with 35. Or work through it piece by piece. But c will be our answer there. So we'd get 49 over 2 plus 21 over 2. We can go ahead and combine those. So 49 plus 21, that gives me 70. 70 divided by 2 gives me 35. Alright, on to 14. So, a new real estate agent is deciding which age groups you should market toward in order to get the most clients. Which of the following measures of the data would be the best to use in making the decision? So, we're looking right here to see which one gives us the most people, right? So the largest market. So our vocab here, which one would give us the most clients possible? We'd be looking for the mode, right? Because that's the most frequent, or the interval here on our graph that gives us the largest portion of people. So if I look here, that would be in this age group, right? So the mode would give us that best idea there how to target the largest percentage, the largest group of people. Okay, based on the information in the figure, which of the following statements is true? Alright, so if we're looking here, for this one, 14, 15. So this graph is skewed, okay? So it's going to be skewed right, because the majority of our data is on the left. So if we think about this, in this relationship, our mode is over here. So we always have the mean being in the between. It's ideally in a normal graph, it's in the middle, but when we have skewed, it kind of shifts it one way or the other. So in this case here, Our mean is actually going to be greater than our median just because of the skewed nature of it. So since it's skewed to the left, our mean is always going to be kind of in the middle there. Our median is just our middle number, right? So since the majority of my data is over here, I'm going to have the relationship of mode, mean, median. If it was the other direction, we just kind of flip the order. So it would be mode, mean, median. In this case here, we can actually go ahead and say for 15. So if we read through our answers, let's start at the bottom. The data has no clear shape. Well, it definitely does, right? So it is impossible. We can make some conclusions from this, right? We have good data. See, the shape of the data is fairly symmetric. So symmetric means it has a nice hill shape to it. It definitely does not, right? The shape of the data is skewed to the left. Well, it's not skewed to the left. It's skewed to the right because we think of opposites here. So the majority of data on our left, therefore we are skewed to the right. If it was the opposite shape, then it would be skewed to the left. So lastly, the shape of the data is skewed to the right. We already said that. So the mean age of the home buyers is greater than the median. That one, kind of tough to logic your way through if you haven't really talked about those graphs. But again, knowing the skew, just thinking the opposite vocabulary, what skewed means, can get us through that. All right, on to question 16 here. So we have a railway company normally charges $35 round trip from the suburbs of a city into downtown. The company also offers a deal for commuters who use the train frequently to commute from their homes in the suburbs to their jobs. Commuters can purchase a discount card for $900, after which they only have to pay $12.50 per round trip. How many round trips T must a commuter make in order to make the discount a better deal? So what we want to think of here is when we have something going to be a better deal for us, right? So if we think of 35x, that's the without the discount, right? On the other case here, we'll have 900 plus 1250x, representing our discount, right? And we want to think when this is going to be less, right? So when that discount is going to be the better deal. So that means it's going to cost us less than this one. When we solve this, we'll end up with, so if I just go ahead here and do a little bit of solving, so again, working through our nice Algebra 1 style skills, we'll end up with, we need to take x or t as they used, so greater than 40 trips. When this becomes greater than 40, that's when this side is actually going to give us a better deal. So we're looking at choice B. Okay, for 17 here, go ahead and take a second and read through it. We have most people save money before going on vacation. Suppose Etten, sorry if I pronounced it wrong, saved $800 to spend during vacation, 20% of which he uses to pay for gas. If he budgets 25% of the remaining money for food, allots $300 for the hotel, and spends the rest of the money on entertainment, what percent of the original $800 did he spend on entertainment? So it's a piece-by-piece problem. So for gas, we're looking at budgeting 800 times 0.2. All right, so that gives us 160 that we budgeted for gas. Right, that's just how we find percentages. If we think about the leftover for this, so we had, let's see, that'd be 800 minus 160, so we have 640 left over. And then we said we budgeted 25% for food. So that means we put 160 into food. So if we go ahead and do a little bit of subtracting here, right? So let's see, we have taken away those. So after our budgeting for gas, we're down to 640. If we take away that 160 we budgeted for food, that puts us at $480 we have left over. Then it says we had $300 for the hotel, so that puts me at $180 that I have left over for that entertainment. So figuring out a percentage of the original 800, we would do 180 divided by 800, which is going to come down to 0.225, right? So just in a calculator, I'm doing it on the side, I'm going to be honest, just easier. And then converting that to a percentage, we'd multiply by 100 or move a 2 to the right. So we'll end up with 22.5%. So again, it's just a piece-by-piece problem. Let's look at 18. Okay, so we have a microbiologist place a bacteria sample containing approximately 2,000, so that's like our starting value, in a petri dish. For the first 7 days, it tripled every 24 hours. Blah, 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 blah. We read some more stuff, right? So it tells us about different variables. So n represents the number of microbes, right? Now, if we think about this, we can see these are written as kind of exponential. So whenever we have something doubling, tripling, quadrupling, or halving, thirding, quartering, we think of that exponential growth equation. So this is going to look something like y is equal to a times b to the x over p. So here, y is like our number or how many we have. A is our starting amount, our initial value. B is the rate, so whether it's doubling, tripling, halving, quartering, whatever it may be. And then p is like our period of time here. So here we're looking at every 24 hours. So if we plug in here, we said we started with 2,000, so I just did y for n, right? It's tripling, so that tells me that I need 3 here as my base. That's the rate at which it's changing. And it says h hours, so that's our time interval. And our period here, it says it happens every 24 hours. So that just kind of converts it to from days to hours type deal. So if I plugged in a certain amount of hours, that would tell me how many days it is for that 7-day period. So our answer here is going to be choice A. Alright, going on to 19. So if a survey is conducted regarding a proposed change in the attendance policy at a law school, the table above categorized the results, surveyed by year of student, 1L, 2L, or 3L, and whether they are for, against, or undecided about the new policy. What fraction of all 1Ls and 2Ls are against the new policy? So we want to think about the probability here. So that's what a fraction of people means, right? So if I think about all of the 1Ls that are against it, I'm thinking about the against, right? So if I'm looking at against, I'm looking at 1L. I can see that I have 16 of those, right? They are both 1L and against that policy. So it'd be 16 of them there. If I look, that's out of 58 total 1Ls. So again, contingency table, right? Against, out of the total. So of all the 1Ls, there's 16 that are against it. For our next part here, we're looking at the 2Ls that are against the new policy. So for 2Ls, there's 12 of them that are against it. So that's another 12, and there's 64 of them total. I just realized I wrote this fraction, probably pretty confusing to you guys there. Okay, so we're looking at just that category of 1L and 2L. So if I'm thinking about totals for them, right? So I have a total of 58 1Ls. And then I have 64 2Ls. So that gives me the bottom of my fraction because I'm just looking at that proportion of the population. Now, the ones that are against, I have 16 1Ls that are against, and then 12 2Ls that are against. So when we add those together, we'll end up with 28 out of 122. And when we reduce that, we'll end up with 14 out of 61. So our choice here is going to be letter A, 14 out of 61. So the key idea here is it's looking at us to eliminate. We're not considering all people. We're just looking at the chances that, given I have a 1L or a 2L, what's the chances that they're against it? So the fraction of all of them. Alright, looking at question 20. So, depending what kind of calculator you have here, I'm going to show you guys a little shortcut that might come in handy, since this is the calculator section. So which of the following expressions is equivalent to this? So if we just go ahead, and this is just one of those nice little shortcuts, so we can do it by hand. You just have to simplify it out, multiply, replace any I squared with -1. But if you have a calculator, we can just type this in directly, because I is actually a button in the calculator. So +5, to get I on this calculator, you press the second button, and then the period. And then it's just up to the third power. Enter. And we get our answer, choice C. If you're curious of how to do that by hand, again, reach out to me. I'd be happy to provide you with the example there. But again, I'm trying to do test-taking strategies here. So whenever we see this I, again, a graphing calculator can work with that. All right, on to question 21. So let me kind of zoom out here if you don't have it in front of you. I'm going to pause for a minute here, get a drink of water. Okay, so we have an exponential function is used to model the graph shown in the figure, and it's written in the form given there. What would be the value of r? So here what we want to do is look at the rate at which the y's are changing. So if we look here, let's just use the first two. So I have 640, and then I started with 160. So exponential means we're multiplying, we're changing by a certain jump, right? So if I divide that, I'll see it gives me 4. I could similarly check 2,560 and divide it by 640. I'll also end up with 4 there. So again, any of them will work. So if I'm solving there, it's the rate that it's changing. If I'm plugging into here, well, 1 plus r is equal to 4. If we solve, we'll find that r is equal to 3. So just working with how things are changing. So again, the vocab of it. All right, on to question 22. So here's going to be dealing with some scales, right? Okay, so we had the Pyramid of Giza, built in the 26th century BC, just outside of Cairo, Egypt, had an original height of 480 feet, 8 inches, before some of the stones in which it had encased fell away. Inside the pyramid, a 53.75-foot passage called the Dead End Shaft, which archaeologists have yet to discover the purpose of. Suppose a museum is building a scale model of the pyramid for patrons to explore. Because the museum's ceiling height, they can only make the pyramid 71 feet, 6 inches tall. About how many feet should the museum's dead end shaft be? So we want to think about a scale. So the real passage, we said, was, where is this number? So let's see, it's a 53.75 foot passage. So if we're going to work with just going on to getting a common unit here, again, the common unit idea here, we have some feet-inch combos, so we're just going to convert everything to inches here. So I'm going to think about my first fraction here, my proportion, being the real passage length. So if we go ahead and think about converting these, right? So we have 480 feet, 8 inches, right? So if I do 480 times 12, calculator, 5,760, plus that 5, right? So that's going to give me 5,765 inches. So let's go ahead and just throw that on top. So that's going to be the actual height of our pyramid there. Now the height we're going to is 71 feet, 6 inches tall. So if I did 71 times 12, and then I go ahead and add in that 6, that's going to give me 858. So I'm putting the height of each, the real and the scale pyramid on each side. Now, over here, we know that it's going to be 53.75 feet. So if I times that by 12, it'll give me 645. And what we want to figure out is x, right? It's going to be the feet length, right, of that museum shaft. So when I calculate this, right, so I'd multiply this over, multiply my x over, reducing division, I'll end up with x being about equal to 95.94 inches, because that's what we converted to. So if I divide that by 12, we're going to end up with the closest answer being here to right about 8. So it's going to be close, so if I did 95.94, and I divided that by 12, I'd get 7.995. So again, our closest answer is going to be 8 there. All right, so we'll make it 8 feet long. All right, moving on to 23. Okay, so which of the following is equivalent to the expression above given that x is not equal to 2? So basically what they're saying is let's rework this thing and make it look a little bit nicer. All right, so on the top, let's factor out that negative 1. We just don't like factoring. We have a negative. So this would be negative 1, and it just switches my signs around. Now on the bottom, if I also factor out negative 1, just to make my x positive, switching our signs and our order a bit there, but it's not going to change much. So those negative 1s on the top and bottom actually cancel out, which is nice. And then if we factor the top, that'll give me, let's see here, we'd get x plus 12 and then x minus 2. And again, I'm going to provide a lot of video resources there on factoring. But if we cancel these terms out, that's on top and bottom, just x is going to be x plus 12. So choice D. Again, this is meant to show you guys how to work through these. I will provide, a lot of other videos that kind of go through individual topics, which is where I would start. Before doing this, I would make sure I have all those topics mastered. Okay, so this is going to be a ratios problem, which is what probably many of us haven't done a whole lot with. So we'll go through this a bit here. Again, if it were me on an exam, I would probably save this till the end. So ethanol is an alcohol commonly added to gasoline to reduce the use of fossil fuels. A commonly used ratio of ethanol to gasoline is 1 to 4. So I'm just going to kind of write that out. So ethanol to gas is 1 to 4. Another less common and more experimental additive is methanol, with a typical ratio of methanol to gasoline, so M to E, or M to G I should say, of 1 to 9. A fuel producer wants to see what happens to cost and fuel efficiency when a combination of ethanol and methanol are used. In order to keep the ratio of gasoline to total additive the same, what ratio of ethanol to methanol should the company use? So first thing, we want to combine ratios, we need the least common multiple, right? So if I'm looking here, the least common multiple between 4 and 9, we can just multiply them, we'd get 36 there for our least common multiple. So to combine these, I want to think about multiplying each of these by 9. So when I multiply this each by 9, I end up with, erase that least common multiple thing there, 9 to 36. And here, because I'm multiplying each of these by 9 to get to that 36. Here I'd multiply each by 4 to get to that gasoline constant of 36, so it'd be 4 to 36. So if I think about this, I want how much ethanol to methanol, right? Because that's the order they're giving us. So ethanol to methanol. So if I'm looking at that, my ethanol ratio is 9, and then my new methanol ratio is 4. So our answer is just going to be 9 to 4. All right, moving on to 25. Okay. We have Julia and Ravi are meeting at a museum. The figure above represents the drives from their homes to the museum. Based on the figure, which of the following statements is true? All right, let's look through these. Let's start with C, because that seems to be everyone guesses anyway. All right, it took Ravi longer to arrive at the museum because his home is farther away. So what this represents is as time is increasing, our distance. So if we're thinking about this, they're leaving their homes. So their homes are represented by where they started at. And then this here is going to be our museum. Because that's, again, the distance. When the distance is 0 from the museum, it means they arrived. So C, it's saying it took Ravi longer to arrive. If we're thinking about this, they're hitting the museum at the same point. So they actually get there at the same time. So it can't be C. Let's go with D. It took Julia longer to arrive at the museum. Again, it didn't take her longer. Since they're arriving at the same time point, that means they actually got there at the same time. B, Julia and Ravi drove to the museum at about the same speed. Well, speed here would deal with how distance and time are related. We can see the slopes don't look the same, so that wouldn't make sense. And again, we could see that the distance here, Julia is farther away than Ravi, so they couldn't have traveled at the same speed. Julia drove to the museum at a faster speed than Ravi. That's actually going to be our choice here because we can see the slope of Julia's line is steeper, so it means that her speed is faster than Ravi's was. All right, looking at 26. We have, if the graph of the function g of x passes through the point 8, 3, then through which point does the graph of negative g, parenthesis x minus 4 minus 6 pass? Okay, so when we're thinking about this, what this means in terms of our parent function, right? So inside our grouping symbol, we think of opposites. So this means we're going to move right 4. The negative out front represents a reflection. And this means down 6, right? So just kind of graphing it out here, right? So if I have some y is equal to, well, they use g here. So let's go ahead and use g of x. So g of x, a, x minus h plus k, right? So knowing how things move related to the parent function. So first thing we're going to do here is we think about what affects what. So we're going to start with that point, 8, negative 3. So if we think about that minus 4, that means we're moving right 4, right? So moving right 4, that only affects our x value. So that'll get me to the point 12, negative 3. Because again, we're moving right 4. Now, when we reflect, right? So we're thinking about how that's going to change. So at the value of 12, negative 3, so if I kind of sketch this to the side of it here. So 12, negative 3, let's call it somewhere over here, right? When I reflect, it's not going to change my x value because we're reflecting over the x-axis. It just moves our point up to here. So basically, it just makes our 3 a positive number. Lastly, we're moving down 6. So that only affects my y value. So then if I had here, 3 minus 6 is going to give me negative 3. So our answer here is going to be choice B. So again, that's just practice working with parent functions, which again, I'll try to provide some further resources on that. All right, 27. If f of x is equal to x minus 1, g of x is equal to x cubed, and x is less than or equal to 0, which of the following could not be in the range of their composition? So if we think about the composition, it's f of g of x. So basically it means I'm plugging that in. So f of g of x is going to be x to the third minus 1. Because again, we only plug that term in where we see the variable x. So if I think about that, it says that x is less than or equal to 0. That means x is going to be a negative number. So if we think about this, well, a negative number cubed. So a negative times a negative times a negative. That's definitely going to give me some type of negative, right? Because 2 negatives when we multiply make a positive, but 3 gives me a negative. So if I have a negative number and I subtract something from it, is there any possible way it's going to be positive? No. So, process of elimination here, there's no way it can be a positive number. Okay, so given this equation, which of the following statements is not true? The y-intercept is 0, 8. The axis of symmetry is equal to 5. The vertex is 5, 8. The parabola opens downward. We're looking for not true here, right? So if I look at this, parabola opens downward. That's true, because there's a negative up front. So it's not that one. Remember, we're looking for not true. 5, 8 is the vertex. Well, opposite of the inside is 5. This stays the same, so that one's true. Axis of symmetry. That's definitely going to be 5, right? That's where we pull our axis of symmetry from. So this comes from knowledge of our parent function again. So ax minus h, this one's a parabola, so it's squared, plus k. Becoming a master of this, which I will, again, provide a nice video for there, that's going to be your best resource to kind of master how to work with the parent function. So process of elimination here, the y-intercept is 0, 8. If we solve this and plug in, so if I plug in 0 for x, I'll actually end up with the y-intercept being negative 67. I just did that on the calculator to the side. I'm going to be honest, plugging in 0 there, so it would be negative 3 parentheses 0 minus 5 squared plus 8. That's not going to be true. Okay, 29. Every weekend for 48 hours, a law firm backs up all client files by scanning and uploading them to a secure remote server. On average, the size of each client file is 2.5 gigabytes. The law firm's computer can upload the scans at a rate of 5.25 megabytes per second. What's the maximum number of client files the law firm can back up each weekend? So here, this should take you guys back to either physics or chemistry. We've done similar problems in algebra, but dimensional analysis, setting up some unit conversions here is ideal. So let's start with our rate. All right, we got 5.25 megabytes per 1 second. So we're talking about here each weekend, right? So let's go ahead and get those over to hours, because we know that an hour, 2 days, so 24 times, so it's 48 hours, right? So let's go, if I want to go from seconds to minutes, right? So I'm going to multiply it by 60 seconds. That gets me to 1 minute. And then if I go ahead and multiply that by my hours, right? Because there's 60 minutes, right? Sorry, just a minute here, my bad. That'll kind of get me over, oh, no, that definitely wants to say seconds. Sorry. It's been a while since I've written these out. So, got our seconds cancel, so we get megabytes per minute. And then I want to go ahead and multiply that by my 48 hours, right? So that'll get us how many megabytes in that amount of time. So when we multiply this out in our calculator, we'll get 907,200 megabytes in that 48-hour period. Now it says a gigabyte is 1,000. So if we divide this by 1,000, that'll give us 907.2 gigabytes that we can upload. And it said each client file is 2.5. So if we divide that by 2.5, we would get 362.88. Now real quick here, logicking our way through. No and no. When I'm thinking about these two options here, so the max I'm going to get up there is 362.88 gigabytes, right? So why this question is trying to challenge us here is we know that we can't do more. So that means the most I could possibly do, I actually want to round down here because I can't quite get to that 363. My abilities to upload just won't reach it. So the most I can do is 362 client files. Okay, let's deal with some angles, it looks like. All right, Main Street and 2nd Street run parallel to each other. So let's go ahead and throw some lines in here that are parallel. So this is Main and 2nd. They're both one-way streets. Main Street runs north, so I'm going to draw it going up. And 2nd Street runs south. So let's use some arrows in there. Compass, right? Northeast, southwest. The city is planning to build a new road, also one way, that runs toward the southeast. So if it's going southeast, southeast. So it's going to be somewhere in here, right? So I'm just going to call that N, my new road. And cuts through both at an angle, right? So just cross them. So it's parallel lines cut by a transversal. Traffic turning off of Main Street would have to make a 125-degree turn. So if I think about Main Street here, if I'm making a 125-degree turn, that means that this value here is 125 because I'm turning onto that street. What angle would traffic turning off of 2nd Street have to make? So I'm thinking about finding this value here, x, right? So if we think about what we know about different angles, right? I know that these two are a linear pair. They'll add up to 180. If I'm looking here, these are going to be corresponding angles. So again, I'll provide some videos on that as well. Different angle measures, angle relations. So since these are corresponding, they're both 125. So if these two add up to 180, because that's the turn I'm making, right, to get onto that new street, I would end up with 55 degrees. All right, on to our fill-in the grid here. Okay, so for our top one here, this is just going to be some solving, right? So, again, I'm going to I'll pause here and show the work type deal. Then you guys can you'll see in a second, it'll just magically pop up, but I'm just going to pause the video. Actually, for sake of time here, I'm going to leave this one up to you guys, just because this video is getting pretty long at this point. This is just solving it out. So we distribute our negative here, distribute our 6 here, combine like terms, multiply our denominators over. Again, it's just kind of going through. You'll end up with h is equal to 11.5, or you could grid in as 23 over 2. Either one of those will work, whichever one you prefer. Again, this is just one of those things, it's kind of working through the solving. So the more practice you get with doing that, the better. All right, let's go ahead and take a look at 32. Okay, so for this one here, we know the difference in costs. So we have that New York and Georgia, right? All right, so New York, we can say, from reading through our equation here, it's equal to 4 times the cost minus 30, right? Because it's saying in thousands, right? So I'm just going to go ahead and do 30 instead of 30,000 there. And then for the next one, so again, I just lopped off the zeros, right? Because this is 30,000, this is 445,000. So we can just kind of get rid of the zeros. Or you could put them in. Either way, you'll end up at the same place. And then here, we've seen that the cost together is, so New York, which I'm just using N for, plus Georgia, is equal to 445. So what I would suggest here is substitution. And again, I'll provide a large video on all the different methods of solving, and plugging that in here. When we solve the net, we'll end up with Georgia being equal to 95. So again, I'm just throwing stuff in a calculator at the side here. When we get to that point, we can go ahead and see here, how many more thousands of dollars does the New York company property cost than the Georgia? So if we think about the different costs here, so New York is equal to 4 times this amount minus 30. So it'd be 4 times 95 minus 30. So then the difference, we just subtract those two. So 350 minus 95 would give me 255 for our difference there. So this would be our answer. So again, just working through setting up that system and solving. Okay, on to 33. We are looking for probability that he will get a car, fuel efficiency of at least 25. So at least 25, right? So what that means is we're looking at going in this direction. So if I look, there is 20 in the interval of being, if I look at this line, right? So there's 25. There's 20 in this interval, and then 6 over here. So 20 plus 6 gives me 26. If I totaled them all up, so this one is at 16. This one over here is going to be at 8. So if I totaled all of those up, that would give me 50 total cars. So 26 divided by 50, it says enters a decimal, so it would be 0.52. Alright, so again, just reading a frequency histogram there. Going into 34 here, for this one, we are given the volume and what it's equal to. It tells us the ratio here, so we're trying to find this length, right? So what we don't know is x. So if we went back to our formula sheet, we'd find out that the volume of rectangular anything, right, prism, we just multiply. So they give us our ratio here. So what I would do is just call this, I'm trying to find x, so what that magical number is for this height. So I just throw an x on each of these terms. We multiply that out, we'll get this. And then through some solving there, we'll end up with just 7. So x is going to be 7. So if we think about our length being that first number, right? So when I go ahead and do 3 times 7, my answer is going to be 21. So that's what I'd grid in there. All right, on to question 35. So if we read through this, what we're looking for is which one of these points is the farthest. So the line of best fit, in general, we want something that kind of splits the data in half. So half above, half below. If I think about that, that's going to be somewhere in between, right? So if we look, the farthest point is up here. It's just saying which one's the most obscure, the farthest away. And then it's saying, shown line of best fit, the length, right? So which month period is the least likely. So length is determined in months down here. So that's just a value of 8. Right, so our value there is just going to be 8. Again, that's just kind of vocab, line of best fit, knowing we're looking for the middle of that chunk there. All right, on to 36. Some exponents again. Okay, so we want to find x here. So first thing, let's combine and simplify here. Right? So if I rewrite this, 2 to the 32 times this. Let me do some work to the side here. So this is 2 to the 32 times 2 to the 32. I'm going to equal it over here to 2 times 2 to the x. Simplifying this, well, 32, that's 2 to the 5th power times 2 to the 32. Now, these have the same base, so we can combine them. So this is 2 to the 2 to the 37th. So again, definitely might want to review our exponent laws here. There you go. Sorry, this should look like up to the x. My bad, not my best handwriting. So if we can rewrite it to that point, to find x, we see here we want the bases both 2, so x is just 37. So our answer here would just be 37. Again, in exponent laws, that's just a lot of practice. All right, last 2 questions here. Okay, so for question 37, you always notice these last questions in each section are the longest. They don't involve any super complex math, just a lot of reasoning. Okay, so for our first one here, we're talking about car 1 and car 2. So we have the first car traveled at an average speed of 64, and it arrived at 2:18. How many minutes had the first car already been traveling before the second car started its drive? So if we think back here, 3 cars all arrive at the same destination at 4 p.m., and it talks about the distances, right? So let's think about car 1 here, right? So we have car 1. And we know that distance is equal to rate times time, right? So that's when we know. So if we plug in here and figure out how long it was traveling for to get there, we went a distance of 144 miles. Our rate was 64 miles per hour. So if we solve that, we'll find t is equal to 2.25 hours. Now, if we want to convert that to minutes, I'd multiply by 60. So that's going to give me a time of 135 minutes. Now, if we look at car 2, right, it's because, again, they said they all arrived at the same point in time. We know car 2 is going to arrive at that kind of same portion in time here, right? So we're going to get there at the same time. Alright, so finishing up, right, we found car 1 there. Now dealing with car 2. So we know what time car 2 started its drive, or the second car. So we know it started its drive at 2:18 p.m. So if we think about starting at 2:18 and we arrive at 4, because again it says all of the cars arrived at the same destination at 4 p.m. So the amount of time between there, right, so there's 60 minutes and an hour. So we have 60 minutes to get to 3:18, and then the additional minutes as well. So if we did 60 minus 18, that arrives us at 42 additional minutes. So the total difference there is an hour and 42 minutes. Or if we think about that, it would be 60 minutes plus 42. That gives us 102 minutes. So our question is asking is, how many minutes had the first car already been traveling before the second car started its drive? Well, that's just saying the travel time of car 1 minus the travel time of car 2. So that'd be doing 135 minus 102 to get 33 minutes. So again, what we would go ahead and grid in there is just the number 33. Alright, lastly, we have question number 38. So I'm going to give you guys a second here. I'm going to pause the video and just erase all this bit here about problem 37 just so we can have some room for 38. So again, pause now if you're still copying anything down. Alright, so for question 38, here we have the third car encountered heavy traffic for the first 60% of the trip. So I'm just going to count it to the side here. Here we're talking about car 3. And I'm just going to kind of keep track. So for part 1, or they call it the first part of the trip, this gives us 60% of the trip, and our speed was 15 miles per hour. Then the traffic stopped due to an accident, and the car did not move for 20 minutes. So if we think about this as like a part 2, we did not move, so not moving for 20 minutes. So I'm just kind of taking notes of these longer problems. You'll find this is a good strategy when you deal with these more complicated problems, is break them down piece by piece. Then we have, after the accident was cleared, the car averaged 30 miles per hour for the remainder of the trip. So it's like part 3. Now, at what time in the afternoon did the third car start its trip? Use only digits for your answer. So they want the time, but like they show us here, 1:25 p.m. is just the number 125. So again, they give you those indicators so you'll always know how to input your final answers. So take a moment now and try to think about how you'd start this problem. Okay, the first thing I would do is let's see what other additional information we might have about this third car. So we have 3 cars, I'm just reading this prompt again, all arrive at 4 p.m. So we know it gets there at 4 p.m. Can highlight that. The first car, we don't need that. The second car, we need that. And here we go, the third car traveled 25 miles. So total distance, 25 miles. Alright, so let's think about what we got here. For part 1 of the trip, we said it was 60% of the drive. Because we're trying to figure out what time they left at. So we got to figure out how long this trip took for them to get there. Because that's what they're asking. If we know how long, we can figure out what time they started at. So for the first part, of that 25 miles, we went 60% of the way. So kind of a part 1 here. We're going to take that 60% as a decimal, so 0.6, and multiply by our total distance there of 25. That gives us 15 miles. Well, if we went 15 miles at our speed there was 15 miles per hour, we can deduce here that this took 1 hour. So I'm going to kind of highlight that, right? So the first part of my trip was an hour long. Now for part 2, it said it took another 20 minutes without moving. So for part 2, we can say another 20 minutes. Because it said we're not moving, so our distance hasn't changed. We just added on some time to our trip. All right, now in part 3 here, we got to figure out, so we have 25 total miles. We've already went 15 of them, and then we didn't move. So what's left over, if we think about 25 and taking away that 15 we've traveled, we have 10 miles left to go. Now we know in part 3, we traveled at 30 miles per hour. So if we think about how long that is, so distance is equal to rate times time, right? So our distance was 10 miles. Our rate was 30 miles per hour. We need to find our time. So if I divide both sides by 30, well, 10 over 30, that gives me my t, which reduces to 1/3, or 0.33. So 1/3 of an hour. Well, there's 60 minutes in an hour. So 1/3 times 60, that gives me an additional 20 minutes. So for all 3 parts of my trip together, we had an hour, 20 minutes, and 20 minutes. So that gives us a total, let's zoom out a bit here, of 1 hour and 40 minutes. So if we want to think about this, we got there at 4 p.m. So if we arrived at 4 p.m. and it took us an hour and 40 minutes, well, let's take it away. So if I go back 1 hour from 4, that gives me, I left at 3 p.m. And then an additional 40 minutes takes me down to 2:20 is the time I left. So the way I didn't put this answer, per their directions here, is I would just grid in 220 is my final answer. Alright, so as promised here, not only did we go through all these questions, I'm also going to kind of highlight some videos for you guys to look at. So different aspects, different keys here, and then I'm going to kind of upload these all to a very distinctive folder with the titles I suggest. So stay tuned here. I'm going to pause the video for a minute and get everything set up on my end. And then the last part of this video will kind of preview the different stuff that you need in order to really prepare in like a suggested order. Again, just giving you some topics to look at. Okay, correction. If you're still listening, then you know that the start of this video actually gave you all that preview order. In hindsight, that made more sense to kind of give you it at the beginning before you take the practice SAT. So hopefully this was helpful to you. And again, always feel to reach out. Again, that contact information is the best way to get to me. It's somewhere up here still. It's right there. So on Twitter, it's at @J_Ciolkosz. It's hard to spell, I know. Or you can email me always at my work email here, jselkis@jths.org.